Hello students, welcome back to our channel Diksha Karnataka. So as you all know, there is only few days left for your KCET 2024 exam. So in this video, I'll be discussing the most important formulas from physical chemistry that you should revise. Okay. So before starting this video, I'll have a small request. So please keep your notes ready. Sit with this video with a pen and a paper. Please note down these important formulas and then you can just revise these formulas. I'll be discussing the formulas from all the chapters that is present in physical chemistry, right? So these formulas are very important for your KCET 2024 exam. So let us see them. So we'll go first, let us see the important chapters that is there. So first is your solutions chapter, a very high weightage topic, chemical kinetics, electrochemistry, equilibrium, thermodynamics and structure of atom, right? These are the topics from where we get questions, okay? So now coming to the first topic, that is your solutions. In solutions chapter, we have first thing that we should remember is concentration terms. In concentration terms, three important concentration terms are there: molarity, molality and mole fraction. So molarity formula is what? W2 by M2 into 1000 by volume of the solution in ml, right? So that is can also be written as number of moles by volume in ml into 1000. Right, this is your molarity. Now when you have remember molarity, the unit also you should know it is capital M. Okay, so please note down this formula here. What is W2? W2 is your mass of solvent, mass of solute. Okay, M2 is the molar mass of solute. M2 is molar mass of solute, and then volume is volume of the solution. Right. Now next coming to molality, we have W2 by M2 into 1000 by W1. The unit of W1 should be in terms of gram. Here what is W1? W1 is the mass of solvent. Okay. And what is the symbol used for? Small m. Okay. So these two things over. Now coming to mole fraction. So mole fraction, suppose we have a mixture of A and B. Okay. So what is the mole fraction of A? That means, or what is the mole fraction of 1 and 2? Two components are there, 1 and 2. So mole fraction of first component or second component will be number of moles of that component divided by the total number of moles. It can be like if 3 components are there, then N2 by N1 plus N2 plus N3. Now here we have one more thing. The mole fraction of first component plus the mole fraction of another component should be equal to 1. Okay. So these are 3 important formulas from concentration terms. Next coming to colligative properties, very important, most important topic from solutions chapter, that is your colligative property. First is relative lowering of vapor pressure, P0 minus P by P0 is equal to XB. Okay, what is P0 here? P0 is pure pressure, okay, and P is partial pressure, right, and then XB is mole fraction of the solute. Okay, mole fraction of solute. Now coming to elevation in boiling point. So here delta TB is equal to KB into M. So here we have substituted again the molality formula. Now depression in freezing point, delta TF is equal to KF into M. That is, so I can write this one as KB into M. In place of M, I have substituted W2 by M2 into 1000 by W1. W1 should be in terms of gram. Same here. Delta TF is equal to KF into M. Molality can be written as this way. Now coming to the last one, osmotic pressure, pi is equal to C into R into T, where C is molarity and its formula is W2 by M2 into 1000 by volume of solution in ml into R into T. What is the R value taken here? 0.0821 and temperature should be in the units of Kelvin. Okay, fine. Now let us see the next one. Next one is Van't Hoff factor. Van't Hoff factor, generally we calculate for degree of dissociation and degree of association. For degree of dissociation, the formula is I minus 1 by N minus 1. For association, it is I minus 1 by N minus 1. Now what is N here? For example, it is KCl, right? After dissociating, it will give you K plus and Cl minus. So N value is 2, right? So, and suppose here, this one 4A as there, they are undergoing association to form you A4. So, N value will be 4 here, 1 by 4 minus 1. Okay. So, okay. So, these were the important formulas from solutions chapter. First is your concentration terms, then colligative properties and then Van 't Hoff factor. Now coming to the next important topic, that is chemical kinetics. Here we have three important formulas. First is your first order integrated rate law. Okay, I have written only the most important formulas, but I will be also telling you the other formulas present in this chapter. So first order integrated law, K equal to 2.303 by T log of A naught by A, right? Log of A naught by A. A naught is your initial concentration, A is the concentration at time T, right? So this is the equation present here. Now what is K here? K is rate constant, T is time. Okay, time can be in any units based on the question given. Okay, now coming to the next important equation, that is Arrhenius equation. Here I'll also tell you the 0th order equation. For 0th order, okay, for 0th order the formula is A naught minus A is equal to KT. Okay, so generally questions are asked from first order, so this formula you must remember. Now coming to Arrhenius equation, equation, like it is, we are having two temperatures at two different temperatures, two K values are there. We have to calculate the activation energy. So log K2 by K1 is equal to EA by 2.303 R 1 by T1 minus 1 by T2. So what is your K2? Rate constant at T2. What is K1? Rate constant at T1. EA is your activation energy. Okay, and R value here you can take 8.314. Okay, so this is done. Now coming to the half-life method or half-life formula for first order, it is very important. T half is equal to 0.693 by K. This is for first order. Okay, for 0th order you can write down T half is equal to A naught by 2K. Okay, this is one more formula is there. Now one more general formula for half-life is T half of any reaction is proportional to 1 by A to the power of n minus 1. This formula also is important. Now these are three important topics from where questions are asked. Okay, most important formulas. Now apart from this, what else you can know? The unit of K. K unit is mole to the power of 1 minus n, liter to the power of n minus 1 second inverse. Okay, so this is the general unit of K. Okay, so these are some important formulas from this one. So you have to revise these formulas, do some numericals from these topics. Do not leave this chapter, very easy and scoring topic. Now coming to next topic from your PU2, that is electrochemistry. So first important formula that is asked is from your Faraday's law. So M is equal to Z into I into T. What is Z here? Z is equal to molar mass by N into 96500, right? Molar mass, N is what? N is the number of electrons used into 96500. Here I is current, T should be in seconds here. Okay, it is mandatory. You must convert it into seconds. Now coming to next one about conductance. So kappa is your specific conductance, 1 by R into L by A. Its unit is S, centimeter inverse. Then we have molar conductivity, kappa into 1000 by C, where C is nothing but your concentration and the unit is S, centimeter square, mole inverse. Okay, so here L is your length, A is your cross sectional area, R is resistance, K is kappa value. Okay, so this is your molar conductance formula. Now next one, the very important Nernst equation, but questions are generally not asked from this topic. We get more questions from these two topics. Okay, so Nernst equation is nothing but E of the cell is equal to E naught of the cell minus 0.059 by N, where N is the number of electrons, okay, into log of product concentration by reactant concentration raised to the power of their stoichiometric coefficients. Now here how to find E naught of the two of the cell is equal to E naught of cathode minus E naught of anode. Okay, so these three are there. Two important formulas that please add it here. First is delta G is equal to minus NF E naught of the cell. This is one important formula that you should know. Questions are asked from this formula also. And another formula is at equilibrium, what happens? At equilibrium, E of the cell is 0. Right? If E of the cell is equal to 0, then what will happen? This relation we will get E naught of the cell is equal to 0.059 by N, okay, log of K. K is nothing but your equilibrium constant. Okay, so these 1, 2, 3, 4, 5, 6, 7. These 7 formulas from electrochemistry, please prepare thoroughly. Learn that at least you should know what terms are there. Okay. Now coming to the next chapter, equilibrium chapter from your PU1, you definitely will get one question from this topic. So first is in terms of condition. Suppose we have a hypothetical reaction like this. Okay, then the Kc value will be concentration of products raised to their stoichiometric coefficients divided by concentration of reactants raised to their stoichiometric coefficients. Now in terms the same thing if these are gases, okay, if these are gases, right, then we can include them in terms of pressure. P of C to the power of C, P of D to the power of D, P to the power of A to the power of A, and P to the power of B to the power of B. Okay, so these are first how to write. Next, this question is all this relation is very important. The relation between Kp and Kc. Kp is equal to Kc into RT to the power of delta Ng. Now how to calculate delta Ng? Delta Ng is equal to number of gaseous products minus number of gaseous reactants. So be very careful, you have to only consider gaseous reactants and products to calculate the delta Ng value. Now we will go to this from here. Ionic this chemical equilibrium is over. Another important topic from chemical equilibrium that you should study is Le-Chatelier's principle. Okay, that is very important. So just revise it. Now coming to equilibrium or for the ionic equilibrium. So first of all, whenever there is a weak acid, the concentration of H plus will be root over of Ka into C. What is Ka here? Ka is dissociation constant, okay, and C is your concentration. Now if it is a weak acid, there will be something called as degree of dissociation, right? It is not a complete dissociation of the acid. So to calculate that degree of dissociation, the formula is root over of Ka by C. Okay, so these two formulas you have to remember. Now what is the relationship between, so same thing, if it is a weak base, it is also applicable for weak base. So root over of Kb dot C, that is the concentration of weak OH minus, then alpha is equal to root over of Kb by C. Okay, where Kb is the base dissociation constant, Ka is the acid dissociation constant. Okay, please note down these things. Now coming for pH and OH, pH plus OH, pOH is equal to 14. So here numericals are asked, they will give you the concentration of OH minus and then they will ask you to calculate the pH. So first you have to calculate the pOH from here and then you have to calculate the pH using this relation. So another formula that we all know is equal to pH is equal to minus log of H plus. Okay. So if it is asked to calculate the pH of a weak acid, first calculate the H plus concentration, then put it in this formula, you will get the pH value. Okay. So next coming to buffer solution. So buffer solutions are of two types we know. One is acidic buffer, okay, and another is basic buffer. So for acidic buffer, the formula for pH is pKa plus log of concentration of salt by concentration of acid. Now what that acidic buffer is made up of what? Acidic buffer is made up of weak acid and salt of weak acid, right? Like for example, CH3OH, this is a weak acid and its salt, that is CH3COONA, right? Like this one acidic buffer can be made. Concentration of salt will be given, concentration of acid will be given, just put it in the formula and you can calculate the pH of acidic buffer. Now coming to pOH, that is or pH of basic buffer. For that we'll have again here two things, weak base and salt of weak base. Okay, so for example, I'll take NH4OH, that is a weak base, and salt of this one, that is NH4Cl, right? So pOH is equal to pKb plus log of salt by base. Okay, so this is all about buffer solution. Now coming to salt hydrolysis. So salt hydrolysis, you should know there are three types of salt hydrolysis. First is the salt made up of weak base and strong acid, another weak acid and strong base, and another weak acid and weak base, right? So we have to, what we can calculate here, the pH value is present. So you have to here you can remember wherever weak base is there, okay, we have to use minus, and for weak acid we have to use plus. Okay, so now if you see here, for pH of weak base and strong salt, the one example of this type of salt we can take is strong acid is like HCl, okay, weak base is NH4OH, right? So this salt will be what? NH4Cl. So the hydrolysis of such type of salt, the formula will be 7 minus half pKb minus half log C. So what I told, if weak base is there, we should use minus. So 7 minus half pKb minus half log C. Now another example is for weak acid and strong base. So if I take NaOH plus CH3CONH, this will give me CH3CONa, right? Salt of weak acid and strong base. So now if you use this one for weak acid, I told you to remember using plus in the formula. So 7 plus half pKa plus half log C. Okay, this trick please remember, it will be helpful. Now when there is a combination of weak acid and weak base, okay, in that case also, before acid there will be positive, before base there will be minus. Okay, so 7 plus half pKa minus half pKb. Okay, now we have this one, this is now we have your solubility product. Okay, so we have this solubility product here. This is also easy topic, solubility product formula. If you remember, we have KSP is equal to, so if any salt is there of the type AX BY, okay, so the KSP value will be equal to x to the power of x, y to the power of y, s to the power of x plus y. Okay, please remember this one. Now for example, we have a salt called as barium chloride. Okay, so this value is x, so x is equal to 1 and y is equal to 2. Okay, so now if I want to make the KSP value for this one, so I will write here KSP value will be equal to x to the power of x, 1 to the power of 1, y to the power of y, 2 to the power of 2, s to the power of 2 plus 1. Okay, so we'll get 4s cube. So this is the general formula to calculate the solubility product. Okay, now let us go to the next topic, that is thermodynamics and thermochemistry. Here the first question is from delta U is equal to Q plus W, that is your first law of thermodynamics. Here Q is your heat provided, W is the work done. Okay, now here one thing that you have to remember is sign convention. So if heat is given to the system, okay, if system is there, heat is provided, then Q will be positive. If heat comes out of the system, then Q will be negative. Now if work is done on the system, okay, work is done on the system, then it will be negative. If work is done, it will be positive if work is done on the system, and if the work is done by the system, then it will be negative. Okay, once again I'll repeat the sign convention here. So please see, work on the system, if work done is done on the system, it is positive. If work is done by the system, okay, then this one is negative. If Q is provided to the system or added to the system, then it is positive, and if Q removed, then it will be negative. Okay, now next is to calculate the enthalpy of reaction. This type of questions are generally asked when reaction will be given. You have to calculate the enthalpy of the reaction. So now how to identify which formula to use and what all are there. So just see here, suppose one comp A is given, A plus B gives you C. Okay, and you have been given with the enthalpies of formation enthalpies of A, B and C. Okay, like for example, data is delta H of formation of A is X, delta H of formation of B is Y, and delta H of formation of C is equal to Z. Now in that case, what will be the enthalpy of the reaction? Enthalpy of the reaction will be products minus reactants. So I can write Z minus X plus Y, right? C value is product, so Z minus X plus Y. Now if the same thing is given in terms of bond enthalpies, okay, when bond enthalpies are given, the formula is like bond enthalpy of reactants minus bond enthalpy of products. Okay, now coming to calculation of change in enthalpy, delta H is equal to delta U plus P delta V. What is delta U here? Internal energy, P is pressure, delta V is change in volume. This part can also, if reactions are there, then delta H is equal to delta U plus delta Ng RT. Okay, Ng you can calculate in the same way, number of moles of gaseous products minus number of moles of gaseous reactants. Okay, next, work done. This is very important formula. Okay, work done is equal to minus 2.303 nRT log of V2 by V1, or this can also be P1 by P2. Okay, now another formula in work done is equal to minus P external into dV. Okay, these two formulas are there for work done. In this, if the work done is in vacuum, okay, In vacuum, P external is equal to 0. So work done will be equal to 0. Okay. Now here one more thing I want to add. Delta U is a function of temperature. So if the process is isothermal, okay, what is the meaning of isothermal? The temperature is constant. In that case, delta U and delta H will be equal to 0. So this one please remember, very important. Many a times the questions are asked from here. So under isothermal conditions, delta U and delta H will be equal to 0. Okay. Now coming to entropy, entropy is equal to delta S by Q by T. Okay. Now coming to Gibbs free energy, very important formula for the spontaneous reaction. Delta G is equal to delta H minus T delta S, where delta G is your Gibbs free energy, delta H is enthalpy, T is temperature, and delta S is entropy. Okay. Now here one more relation we have, Cp minus Cv is equal to R. Okay, this is there, and you can remember here change in internal energy by time is Cv, and change in enthalpy with, sorry, not with time, temperature, it is your Cp. Okay, so this one is important and remember here. Okay, now coming to your another last physical chemistry chapter, which is very important, that is the structure of atom. From here, first of all, you should know hydrogen spectrum formula, that is 1 by lambda is equal to RH into 1 minus N1 square minus 1 by N2 square, where RH is nothing but Rydberg constant and its value is 109,677 centimeter inverse. Okay. Now here you should know how to take N1 and N2 properly. So if we have, you know, like for Lyman series, N1 is equal to 1, N2 can be anything. Lyman, then for Balmer, this is 2, this can be 3, 4, anything. Then for Paschen, we have 3, 4, 5 something. Then we have for bracket, this is 4, this is 5, this is 6, this is 7. Then we have P fund for this is 5, this is 6, 7. Like this it will increase, right? This one you should know. Now next one, angular momentum, mvr is equal to nh by 2 pi. Here you should remember that angular momentum should an integral multiple of h by 2 pi. Okay. Now coming to your radius of Bohr's orbit, that is 0.529 by n square by z, where n is the orbit number, okay, and z is the atomic number. Okay, clear? Now coming to next one, this is also very important, de Broglie's wavelength, very important formula, lambda is equal to h by mv, or you can write h by p. Okay, so based on the question whether mass is given, velocity is given, or momentum is given, p is momentum here. Now again next question, Heisenberg uncertainty principle, delta x into delta p is greater than or equal to h by 4 pi. Now next is energy of Bohr orbit. So for any nth orbit, the energy formula is minus 13.6 z square by n square, units is eV. Okay, so z is again the atomic number, n is the orbit number, okay, the shell number. Okay, okay. Now here are questions from quantum numbers, very important topic. Quantum numbers from structure of atom is highly scoring and easy topic. Please revise this topic and go. So we have 4 types of quantum number. Principal quantum number, the range is from 1 to infinity. Azimuthal quantum number, so this one I'll explain with an example. Okay, so for example, see, I'll take principal quantum number as 3. Okay, n is equal to 3. Then what are the azimuthal quantum number? You can see the range from L is equal to 0 to n minus 1. So L values that are possible is 0 to n minus 1, means 3 minus 1 is 2. Okay, so these are the possible L values. Now for each L value there can be ML values. Okay, the magnetic quantum number is minus L to plus L for each azimuthal quantum number. Now so what will be the ML values here? Here ML value will be 0. Here the ML values will be minus 1, 0 and plus 1. Here the ML values will be minus 2, minus 1. So for L is equal to 1, minus 1, 0 and plus 1. For this one it is minus 2, minus 1, 0, plus 1 and plus 2, right? So these are the ML values, magnetic quantum number. For every L value there will be magnetic quantum numbers. Next, your spin quantum number, the values lies between plus and minus half. Okay, now let us see the most like one of the easiest and scoring topic, that is your nodes. Okay, so radial nodes formula is n minus L minus 1. Angular nodes formula is n. Okay, and total number of nodes is n minus 1. Total number of nodes is n minus 1. Now if you see this, let us see this with an example. Suppose I have an orbital called as 3p, right? In 3p, what is n value? N value is 3. L value is 1. L value is 1. right? So now let us calculate the radial nodes here. Radial nodes is 3 minus L value is 1 minus 1, that is equal to 1. Angular nodes is, your angular node will be equal to only L, right? So L is also 1. Then total number of nodes is equal to 2. 2 is also 3 minus 1, right? So like this you can calculate this one. Now one more thing I want to tell here, in solutions chapter, okay, here you also should focus on your Raoult's law, okay. So for Raoult's law, we know P total is equal to P naught A XA plus P naught B XB. Okay, this formula you can remember, very easy formula. And then one we have Henry's law. In Henry's law, P of the gas is equal to Henry's constant into moles fraction of the gas. Here you should remember KH is inversely proportional to solubility. Okay, fine. So these are some, see, I won't say these are all the topics that is covered in the physical chemistry, but these are the most important formulas from where more number of questions are asked. So just keep a note of it, revise them in the last day of exam. If you are having time, please revise the numericals from these topics, okay. So if you have found this video useful, please like, share and subscribe the channel. Thank you for watching and all the very best for your exam. Thank you.